Okay, this is for my periods 1, 3, and 6. I gave you guys a review test to do, which basically has covered everything that we did this not this marking period, this entire year. It's going to count for a good amount on the report card. We haven't done one like this, so I wanted to go over this particular one, along with a couple others with you. So let's read this. The temperature T of a given cup of hot chocolate after it has been cooling for T minutes can best be modeled by the function below, where T sub O, we can say that T sub O is the temperature of the room and K is a constant. Our equation reads natural log of T minus T sub O equals negative K times T, which T, remember, stands for minutes, T minutes, that's time, plus 4.718. A cup of hot chocolate is placed in a room that has a temperature of 68 degrees. After 3 minutes, the temperature of the hot chocolate is 150 degrees. Compute the value of K to the nearest thousandth. Only an algebraic solution can receive full credit. Using this value of K, find the temperature T of this cup of hot chocolate if it has been sitting in this room for a total of 10 minutes. Express your answer to the nearest degree. Only an algebraic solution can receive full credit. All right, so let's look at this. We have an equation. I'm going to write this equation out a little bigger over here, and let's label what everything means. So we have the natural log. Remember, that's log base E of T minus T sub O equals negative K times T plus 4.718. All right, now we have, remember, the big T stands for temperature of hot chocolate. The T sub O, that stands for, T sub O is the temperature of the room. So this is the temperature of room. Let me see, the K is the constant, so that's a constant value. And the T stands for minutes, so time. Time and minutes. All right, so we have 4 different things here. You need to have at least 3 of them to find the other one. So let's go down to the second part. It says a cup of hot chocolate is placed in a room that has a temperature of 68 degrees. All right, so now we have our room temperature right there. After 3 minutes, the temperature of the hot chocolate is 150 degrees. Compute the value of K to the nearest thousand. Okay, think about that for 1 second. All right, so back to looking at this. We have SmartBoard's acting up right now. Okay, so we have, looking at that information, we are going to plug in place of T, the temperature of the hot chocolate is going to be 150. Let me see, the room temperature is 68 degrees. And our time is going to be 3 minutes. And we are going to solve for K, which is possible because we have 3 out of the 4 parts. So I'm going to write this now. Natural log, the log base E of 150 minus 68 equals negative K times 3. You could have put negative 3K, either way, it doesn't matter. So plus 4.718. Now I'm actually going to do, you don't need to do any type of maneuvering here. We can just do the natural log of 150 minus 58. I have my calculator here. So I can just plug in natural log of 150 minus 58, or 68 rather. And I'm going to get, let's see. So that would be the natural log of 82. You don't have to even do this step. You could just do it right here, and you don't even have to put the 82. I'll just do that this time. plus 4.718. Now we have to do ln of 82 if you didn't already do it. So the natural log is, let's see, let's keep it like that, matter of fact. So I'm going to do the natural log of 82, and then I'm going to subtract 4.718, and then subtract 4.718. So that's going to give you natural log of 82 minus 4.718 equals negative k times 3. Then I'm going to divide this by, you know what I'm going to do? I'm going to switch this around. So I'm going to have the natural log of 82 minus 4.718 equals negative 3k. I can switch these around here because of the commutative property, and I can put the negative with either one. If you're multiplying by the negative, the whole thing's going to be negative. So it doesn't matter if it's with the 3 or the k. I'm going to divide now both by negative 3. Now I'm going to plug this entire thing into the calculator. So let me go ahead and write this now. The natural log of 82 minus 4.718 all over 3 equals, well, all we have left is k. So let's plug that in. Okay, it also said compute that value to the nearest thousandth. So when I plugged all that in, I got the value of negative 0.1037, which would give me negative 0.104 for k. So we have an approximate value of k now. All right, now we have our value of k. Now we have to look at the second part of the question. It says using this value of k, find the temperature T. So this time we're trying to find the temperature T, not anything else. Find the temperature T of this cup of hot chocolate if it has been sitting in this room for a total of 10 minutes. That's our little t in the equation. Express your answer to the nearest degree. All right, so let's go back to our equation here that I had circled in red. And that's going to be, I'll just rewrite it down here. Natural log of big T, which stands for temperature of the hot chocolate, minus T sub O, which is the temperature of the room, equals negative K, which we now have K, times T, which is number of minutes, plus 4.718. All right, so now, we're looking for big T. So we need to do the natural log of T. That's the one we're looking for. So I'm actually going to do that in green because that's the one we're actually looking for. All right. We know what the temperature of the room is because it said that in the first part, 68 degrees. So we have big T minus 68 equals, now we have our value for K. So I'm going to put negative 0.104 times 10. We have 10 minutes. Move this over a little bit. Okay. Well, I'm going to have to erase some, so hopefully you have this down. All right, so we have negative 0.104 times 10 plus 4.718. All right, so let's do natural log of T minus 68 equals, now we can do all this side, that's just simply plugging stuff in the calculator. So I'm going to go ahead and do that. Okay, figured all that out and got 3.678. And now we just have a simple, relatively simple logarithmic equation. Remember, ln is log base e. So we have log base e of t minus 68 equals 3.678. Remember, this is in log form. We can change it to exponential. So that's going to be e to the 3.678 equals t minus 68. Now we add 68 on both sides, add 68. We have e to the 3.678 plus 68 equals big T. Okay, when I plug that in a calculator, I get 107.56 equals T. But if we go back up to the question, it did say to round to the nearest degree. Don't do all this work and lose a point for something simple like that. This is not the nearest degree. The nearest degree would be this place right here. So we need to look at this 5. This 5 makes that go up. The 7 go up to an 8. So our final answer would be 108 equals T. And it's 108, what were we looking for? Temperature. So we can say 108 degrees. Label it. There you go. All right, now I'm going to go over number 36. Gotta close the door real quick. All right, looking at this problem. It's similar to the last one. I'd say it's a little easier from the looks of it. All right, let's read it. The growth of a certain strain of bacteria is modeled by the equation G equals A times 2.7 to the 0.584, that's 584 thousandths, T. And G is the final number of bacteria, A is the initial or beginning number, T is the time in hours. And approximately how many hours will 4 bacteria first increase to 2,500 bacteria? Round your answer to the nearest hour. So we're going to need to find T here. So let's identify what we have. 4 bacteria, it says in approximately how many hours will 4 bacteria first increase to 2,500? So hopefully as you're reading this, and if you're looking at it right now, you know that the 4 bacteria would stand for the initial. The 2,500 is going to stand for the final. And the T for time is the one we're looking for. So we can plug it in. Say G, which is our 2,500, equals A, which is our initial, which is going to be 4, times, that 2.7 is just a constant in there, to the 0.584 T. All right, what you have now is an exponential equation. The reason we know it's an exponential equation is because the variable is in the exponent. So that tells us it is an exponential equation. So we can do a couple things here. I would suggest you sit back and try it before you just watch me do it. Okay, hopefully you tried it. First thing you'd want to do is divide both sides by 4. Remember, that 4 is not being raised to the power. Only this 2.7 is. So we can justify, or we can divide that 4 legally. That's something we can do. We could not divide that 2.7. We also don't want to divide 4 and 2.7. Don't want to do that. That's a no-no. So, but we can divide the 4s here, get 1 and 1. And 2,500 divided by 4 is, I'm going to have to do that on the old calculator just to make it quick. All right, so that's 625 equals, hold on one second. All right, so
I got this paper too for you.
All right, so what you're going to do, we have 2,500 divided by 4, and that's going to give us 625 equals 2.7 to the 0.584 T. All right, so now take a second, look at that, and see if you can do that. All right, hopefully you were seeing that you needed to do some type of log with this. In this case, You can really use log base 10 or natural log. It depends on what you have on your calculator. I'm just going to use the natural log. So I'm going to take the natural log of 625 equals the natural log of 2.7 to the 0.584t. And remember, whenever you log, one of the properties you can use is bringing down the exponent. So now we can bring down this exponent, and we end up with the natural log of 625 equals 0.584t times the natural log of 2.7. All right. Now, what we want to do at this point is divide both sides by that natural log of 2.7. These are being multiplied over here, so I can divide by the natural log of 2.7. And I'm going to do that over here, natural log of 2.7. So now on the left-hand side, we'll have the natural log of 625 divided by the natural log of 2.7 equals 0.584t. And you could get a value out of your calculator for this left-hand side, or you could just divide both sides by 0.584t, not t, just by 0.584, and then do the other side by the same thing, divide by 0.584, and I'm going to take a second and do that in the calculator. So do the same. Okay, when you put all that in the calculator, all this, you're left with t on the right-hand side. So t is equal to 11.098. All right, in the question it says round to the nearest hour. Now that might be kind of confusing. What you have to think about in this situation is, at what point did it reach 2,500 bacteria? So the way it's worded is kind of questionable. I would say the way it's worded, you could justify saying 11 hours, because you get 11.098. So to the nearest hour, you could say 11. But you could also consider the fact that since it takes more than 11, then it would really take 12 hours. Because at 11 hours, you're not quite to 2,500 bacteria. And just to make sure, I went to the exam that this came from, which is, where is it? Thought I had it. Just a second. Right, this actually came from a test that was taken in 2002, June 2002. And if you read what's on the right-hand side, which I'm not able to use my marker on this, but you see what it says, the bacteria. So I'm looking at this part right here. The bacteria does not increase or do not increase to 2,500 until after the 11th hour. So therefore, the answer is 12 hours. So that's what they had. I think the way it's worded, it makes it questionable, but here's an official answer saying that it should be 12 hours. All right, so that's what we'll go with. Okay, the reason why I put number 16 on here is because this is a typical question that you will see on an Algebra 1 exam. Except on Algebra 1, they'll have these same things. If you remember the Algebra 1 exam, they'd say, you know, x squared plus 2x minus 3 is subtracted from 3x squared minus or plus 2x plus 3, something like that. The trick when it said that is you had to put this part first and then subtract this from it. That's the trick. It's the same thing on this problem. The only difference is this has fractions in it. So when you see it like this, subtracted from, you have to do 5/8 x squared minus 1/4 x plus 2 minus, now make sure you do parentheses because that minus has to be distributed, minus 7/8 x squared minus 3/4 x. All right, so what I would do, I don't know, a lot of different ways to do this. I would just distribute this negative and then just combine like terms. So 5/8 x squared minus 1/4 x plus 2 minus 7/8 x squared. Now, minus with a minus, that's going to be plus 3/4 x. Now I can just combine like terms. I have 5/8 x squared, and I have a negative 7/8, which makes it pretty easy because we don't even have to change denominators. So 5/8 and then a negative 7/8 is going to be a negative 2/8 x squared. So I consolidated those. And then we have negative 1/4 x and 3/4 x. So they actually made this one easy on you because you don't have to change denominators, and I picked this problem from a test. So I think this one on the test, if you got it, would be a little easier. Hopefully, even if it was different denominators, you shouldn't have a problem with that. All right, so negative 1/4 plus 3/4 is 2/4 x, and then plus 2. Now, if I look at my answers, I don't think I see that answer. However, you do see the fact that we can simplify. So that's going to be negative 1/4, remember, because 2 goes into 2 once, 2 goes into 8 4 times. So we'd have negative 1/4 x squared plus 1/2 x plus 2. So let's see if that answer is there. And it is. We have C. All right, so there you go. I only did 3 problems. I thought I was going to do more. That's all I had time for.